Hello, I am Nugrate, and this is a demonstration and overview of my GUI-based docking script written in kOS. I will be demonstrating the script with all three of these docked craft for various different functions within the script. We will be starting with this small pod. So let's get that undocked. Switched to clear of the station, and the script running. Okay, there it is started. This script consists of two primary modes with two secondary things. The two primary modes are burn mode, which we'll be going over first, and translation mode, which we'll be going over second. Status display subfunction will be shown for both burn mode and translation mode, and port selection will be gone over in tandem with translation mode. First up, burn mode. You can see the three options down here: kill relative speed, burn towards target, and close with target. These are very similar to standard actions a player undertakes in KSP. Kill relative speed is the classic set a target, configure the nav ball for target mode, and burn retrograde until your velocity is 0. Let me demonstrate that now. Needs a little bit of base speed in order for it to actually work. So turn it on, it flips retrograde, and it'll burn shortly. A couple things about this: it needs to be within 1 degree of the target vector, retrograde in this case, for 5 seconds before the burn is allowed to start. This is intended to let the craft stabilize before it burns. You can see the delta V, the time left on the alignment, it just vanished there, and now we've stopped. Last reported speed was, relative speed as you can see, was 24 millimeters per second, so we're basically at a dead stop, back to the burn modes. The other next one we have is burn towards target. This is fairly straightforward. If you use a positive number, it's the equivalent of lining your ship up towards the target, burning until your prograde marker is on this target at a given speed. Or even if your prograde marker is, say, over here, it'll burn over here and move the prograde marker to the target. I'll demonstrate that now. If you give a negative result, it'll burn away from the target. So here's a prograde. Now I want to close with the target at 1 meter per second. You can see the DV on the burn, my current relative speed. Notice we mostly line up with retrograde, but not quite. What'll happen as it burns is it'll push prograde onto that point, and there we go, more or less. 1 meter per second is a bit low to get good accuracy. Let's kill our speed again. And, well, actually, let's just demonstrate burning away from the target. I just told it I want to be going away from the station at 20 meters per second. So burn is 21 meters per second because I'm going towards the target at 1 meter per second. I want to be going away at 20 meters per second. So there's that. The last burn mode is a bit more complicated. This is intended for closing with a target as it sounds. How it works is you specify a given speed and a distance relative to the target you'd like to stop at, and the script will close with the target at that speed and then decelerate until it reaches your specified distance, which in theory is when you reach 0 meters per second. It's not precisely that, because I don't quite have the math worked out right, and there's some weird stuff that happens with positions on various physics load states that I don't quite have the logic worked into the script to fully compensate for it. So let's close at a rate of 10 meters per second and stop at a distance of 100 meters. Status display is doing the same thing as before, except for now we don't stop as soon as the burn is done. It keeps running. And what it'll do is it'll continuously error correct to keep the prograde marker pointed at the target. If it's closing too fast, it'll slow down. If it's closing too slow, it'll speed up. If the prograde marker is drifting in one direction, it'll go burn off prograde to get the prograde marker back on target. I've used this to close with stations at significant distances. Makes certain aspects about my life a lot easier. Because currently the speeds and distances are so small, it's kind of tumbling randomly until it starts decelerating. Part of the reason for the random tumble is it's just trying to make a bunch of micro corrections, which it can't quite do perfectly. Just the math isn't perfect, and nor is KSP. As soon as it starts decelerating, you'll see the target speed here start dropping, which will start forcing kind of a constant steering, and it'll stabilize a lot more once it actually starts slowing down. It's designed to give itself about 60 seconds of deceleration time. This was, or 1/4 of a ship's acceleration, whichever one of those two numbers is smaller. Okay, we've gone close enough. We're trying to slow down. We're lining up, and there's the engine, and you can see the continuously updating burn DV is stabilizing at a few tens of millimeters, and the relative speed is dropping towards 0, as you'd expect. Once we get within a certain distance and speed, this burn mode will automatically change to the kill relative speed mode. There's one of the errors I mentioned, that wobble. On load, the craft's position changes. Not sure exactly why it does that, but it does happen and has been kind of a problem. It's partly why I'm also doing this at lower speeds. I'm less likely to ram into something. And so here's the all stop. And there we are, stopped relative to the target. And next up, I'll be going over some of the translation functionality. At first glance, the translation stuff is a lot more complicated. I've got a lot more options to play with. Rotation only, full translation, translation settings, face target COM, align relative to target, and align with a target port. First up, face target COM. Notice that changed this display. I now no longer have the ability to set these distances. I can only set speeds, and I can only set distance or speed on forward or backwards. So let's load the current distance. We are that far from the target center of mass, and let's start translating. So what the ship's going to do, it's going to point at the center of mass, and then I can control the distance. So let's close, say, 30 meters. Every time I change one of these fields, I have to push the update button in order for the script to actually register that I've changed it. Not always the case for all of the things, but mostly how it works. So, update. how the translation logic works is based on the translation settings and this acceleration limit, I convert the distance into a speed using this acceleration. The linear motion equations are used for this, which gets me a very smooth, very controlled deceleration towards the target, which is extremely valuable for docking. Keeps everything nice and stable. Status display is also very different. We now have a bunch of things. We have got the absolute distance, absolute speed, the distance on the 4 vector, forwards and backwards, the speed along that vector. We also have the, I apologize for the cat, we also have the top vector and distance and speed, and the starboard vector distance and speed. So this is up, down, this is left, right. These values at the moment are kind of not relevant because it's center, or at least the distances are not relevant because it's center of mass. They're not 0 because of slight errors in the mathematics. I know I'm sampling things, but they are close enough to be functionally 0. Yeah. Again, sorry for my sniffly cat. So there's that. Again, with the distance mode, I can also set a speed. Say I want to close at 0.1 meters per second. I can update that, and now I am creeping ever so slowly closer to the target. I can also 0 that out and go backwards. So, target relative alignment. This ship has a facing on its nav. It's what direction it's pointed in the nav ball. These relative target alignment, these target relative adjustments are pitch, yaw, and roll adjustments to the target. By default, it is set for a yaw of 180 degrees. What this means is the up direction will be the same for both craft, as well as the usual your left is my right, my left is your right type shenanigans when two people are facing each other head on. I can also use all 3 of these axes, forward, up, and left, well, in distance mode as well as speed mode. Let's load in the current distance. So, according to the center of this ship, it's currently the center of mass, if I remember my math right. I am 9.02 meters forward of the center of mass, 12.68 meters below the center of mass, and 25.84 meters to the left of it. Let's switch to locked camera, and that'll become more apparent. So that is up, that is left, and that is forward. So you can see we're forward and below, and to the target's left. So let's back off to 15 meters and 0 out the up direction. It'll calculate what it needs to move along that axis and to smoothly get to that location, as well as the same usual smooth deceleration. This is again combining all of these into a single velocity that I need, and then, or rather a distance, straight line distance, and then doing the same straight line distance calculations that it was doing before. So now I'm 15 meters ahead, so I'm actually ahead of the target, and let's 0 out the right. As mentioned, these can be speeds, so let's switch distance to speed and go up at 1 meter per second. Notice it just smoothly handles closing one axis based on distance while another axis is running on a fixed speed. So let's switch that to -1, and we'll start going down. Forwards works the same. Here's -1 forward. Here's backwards. Here's forwards. And these, you know, naturally, putting them all in speed, will correctly update here, and the speeds along the various axes will get very close to the given targets. So let's go back to all distances, 0 our distances, and go back to the 15 meters. Next up, we'll be talking about align with port, so let's go there. Click, okay. First I need to select a docking port though. Automatically kicks me over to docking port selection, spits out an error message on the console telling me I made a mistake. So let's scan the target, and it's identified all of the docking ports. There are by size first, 1.25 meter and the 0.625 meter. So let's leave it on 1.25. It, by default, right, center of mass alignment. Silly me. By default, it'll pick the largest size port that it knows of. It's got a database of a couple different port sizes. It also does part highlighting, which is toggleable if it annoys you. The yellow port is the ones currently selected in the drop-downs here. This is the ship. If I had more than one, they would show up here. This is the target. It's got 3 ports. It's actually got 6 of that size, counting this one, but they're closed, which means they aren't valid ports. As I change the target port, the highlighting will move around. If I select a given port, those 2 ports will turn green. Let's look at the other size. Notice I've still got the 1.25 meter pair selected, so they're still green. But now, because I'm thinking about the 0.625 ports, those ones are the blue and yellow ones. So let's go for this one, clear the selected ports, select this pair, translation, align with port. As always, load our current distance, update the translation. Our camera jumps because our control point changes. Sickening as that is, sorry. Here we have, let's get off of locked camera. We'll probably go back to it in a moment. Here we can give an exact number of degrees of rotation we want relative to the up of this port. So 90 degrees, 90 degrees the other way, and back to aligned. This is very useful for on-orbit assembly type operations and various other things. These distances, by the way, are now port relative, so I am behind the port, I am below the port, and I'm slightly to the right. So let's zero out that, change this to 5 meters, update, translate forward a bit, zero out the up-down distances, and it recomputes its flight path very nicely on the fly. Wait until we're aligned, go into the status display to, watch how the alignment is going. Back to translation, speed 0.25, closure rate. This script automatically ends if a selected set of docking ports registers as docked. And that's it for those features of translation. Next up, I'll mention some of the more advanced stuff related to center of mass targeting. I'm sorry for the wobble, that just happens on this craft when docking occurs, particularly if it's energetic. So, time to undock our next example. Targeting the ship. As before, getting rid of this core, and now opening this one. Same program. I'm just going to be showing how it works with claws. So, port selection, scan for target. Found a target. We have a shielded port, which is usable because we're controlling this ship, so we have the ability to open the shield. I've been meaning to program that in as automatic if you select it as your current port, but I haven't gotten around to it yet. It'll also see the .625 on the back end, and it will see the claws. Those are selectable, just like any other docking port. So let's select the starboard claw. We'll have to go in and arm it ourselves. Again, something I've been meaning to add, but haven't gotten around to it yet. Now, again, load our current distance, start translation. There will be an immediate flurry of translation as soon as it's done aligning. Because of the rotation, the claw changed position significantly. And that's the point that the distances get measured from, which makes it extremely useful for craft like this that are that have an off-axis docking port or an off-axis claw. So let's go to our earlier 15 meters before ahead of the craft. Zero out the up arrow and start zeroing out the left and right. So, because this ship is no longer on there on the same side as this, it's much more, the center of mass of this station is much more balanced. And you can see how we've lined up with the center of mass. Let's switch to this, see where, you can see how the center of mass is located by how the camera rotates. And you can see how the claw is lined up on that center of mass. We can, of course, change, say, the rotation. Maybe we only want to yaw by 90 degrees as opposed to 180. So we update, the ship spins, and it retranslates immediately, well, as soon as it's done recalculating everything, to position the claw in the exact same place it was, facing a new direction. This can be kind of problematic for certain maneuvers if you're close into a target, but generally perfectly fine. So let's go back to the 180. You can also, roll as well. And just to show it does work if you change claws, we are controlling this one. I'm going to change it to this one. Bump. And it immediately recalculates everything and starts trying to translate this to the same position this claw was at. like before, we can set a forward speed and close until we've docked with that. So now that I've demonstrated all that, I'm just going to go in here and select this basic docking, the 625 port, select it, whoops, quickly update the script, because it changed the control point to be that docking port, which was gonna kinda potentially crash with the station, so don't want that. So again, 5 meters ahead, 0 out, the other axes, update, and the translation happens. This is pseudo-manual control. A lot of the operations happen automatically, but you still have to manipulate everything about where you are and what's going on. There is a manual mode, which I will demonstrate shortly, as soon as this finishes coming to a stop, or try to demonstrate. It's been a while since I've used it. I like the automatics. They are very convenient. So there's that. So rotation only, docking port alignment. So we will always be lined up based on our roll. But now the translation is disabled, and I have full manual control of translation. Away from the docking port, towards the docking port. There's up. There's down. Speaking of, I need to close the up more. Let's get closing. And so with this, you have, you know, your usual full manual translation control, assuming you can remember which button thrusts you in which direction. Precision mode is useful, if not necessarily essential. So let's speed up a touch. And docked. And again, the somewhat chaotic tumble as the script kind of disengages and the SAS fights things and all that. Lastly, for one of the features in the script, there is a tumble compensation. So let's stabilize the station. Here's the station stabilized, and we'll undock this one. I'm using this one for the demo because it's got significantly more translation thrust than the other two, and to properly use the tumble compensation, you need thrust. Oops, wrong direction. Here we are, backing away. If you don't have thrust, it'll end up making you go farther away from the station as it tries to go closer. So, face target center of mass. Let's right, set the target. Load our current distance. Yeah, let's call it at 20 meters. Okay. Notice the tanks are basically full. This will eat a lot of fuel. The translation setting, here's the tumble compensation option. We'll go over what that does shortly. I'm switching back to this station. A little bit of pitch. Get that started. Little bit of yaw. Well, that's a bit much. Well, Sure, let's go with a bit more. And then a little bit of roll. Now that's a nice, chaotic 3-axis tumble. Well, let's get our port selected first as well, okay? Doesn't matter that we're still in center of mass mode. Notice I've got 2 port options as well. Let's go for the number 1 port, which is that forward one. We will be trying to dock to that green docking port. So, this is best viewed from locked camera to really see what happens and how this works. Engaging tumble. And now we've matched how the station is tumbling. Port alignment, everything to distance, load current distance, align, zero out, the up, down, and left, right. And so despite this chaotic tumble of the station, I can just smoothly enter the various distances and the script will automatically deal with it. Notice I'm continuously burning fuel to constantly deal with this tumble, but it is dealing with it. Closure speed 0.25 and update. If I'm too far away, the attempt to synchronize with the tumble of the station will not work. The required sideways velocities will simply be too great and it won't be able to, and it just won't have the acceleration needed. Too close and you start hitting things, which is not necessarily what you want. So you need to get close enough that you can turn it on, and then you have to close quickly in theory. Notice for those few simple seconds, I've already burned nearly 50 units of monoprop. Probably less than a person would actually burn trying to do this, but it's significantly more than what this script usually burns. Because as soon as we dock, I'll show you what this craft expended. And that included engine burns. So that, remember how much messing around I did in that one? This burned nearly as much as that. Or this burned nearly as much fuel as this one did. And I did a lot more with this. So the tumble is very fuel intensive, but very useful if you're trying to dock to a thing you don't have control over and accidentally bumped. So that's my docking script. Hope you've enjoyed. As before with the path finding and path following, code will be in the description below.